Hello guys, in today's video we're going to be learning together library in C. Without further ado, let's get started. So, what is C library? C library is a collection of precompiled function and definition. Okay, and definition. So C library is a collection of precompiled function and definition. So why do we need C library? Why do we need library in C? Now, let's look in a scenario whereby you write a function every day. Let's say for instance, you write a function for addition every day, subtraction every day, multiplication every day, you know, and writing those functions is a lot of stress. Okay, addition, write addition.c, okay, every day, like the function of addition, or let's say for instance, for example, let's use, like, you want to write a function for mathematics. Okay, mathematics. So, and this function comprises of, I mean, let's say 100 functions. Okay, 100 functions of mathematics alone. Okay, and you write this function every day. 100 functions, which is abnormal. And on a real sense, it will be very tedious to write 100 function every day, 100 question function, and those functions same thing. Okay, we are writing the same function over and over and over again. So the reason why C now introduce library is because they want to eliminate writing function over and over and over again. That is, when you write a function and that function you want to use it in the next program, you can just store that function inside a library. So in a nutshell, a library is just a container, okay, a container or folder that contains all your functions. Okay, so all your functions that you wrote, you now keep them inside that library. So whenever you need that function, for instance, you created a math library. Okay, math library. So whenever you need to use math function, you just call on math library straight. Just call on math library, and it will save a lot of work, because all your everything has been, all the packages, all the packages that made up the math library, the math function is already there. It's already in the library. You just call the library, and you use it in your program. It saves you the stress of writing another function of the same type. So that's the reason why of introducing library in C. Now, there are two types of library in C. We have number one, static library, and number two, we have shared libraries, and number two, we have shared or dynamic libraries. So what is static library? Static library, okay, are collection of codes of a collection of object code a collection of object code or object files that are linked into your program or let's say that are linked into your program during the linking phase of compilation, okay, of compilation, and are not relevant during runtime. Right. So static library are a collection of object files. That is all your function. Now, for example, okay, for example, you created addition.c, subtraction.c, and you have multiplication.c. Now all these addition.c, subtraction.c, multiplication.c should now, so now this is the function that you wrote, okay, function, okay, that you wrote, and this function you want to create a static library with these functions. Okay, now this, for you to create a static library with these functions, you have to compile them into an object files, okay, to an object files. Okay, now into an object, into object, okay, let me just say into object files. Okay, into object files. So all your function that you, this addition.c, for all your functions, you compile them to an object code. Then you now link them into the program, like into your program, okay, during the linking phase of compilation. Don't worry, I'm going to do a demo on this and explain in much details. Now let's go to there are advantages and disadvantages of static library. Okay, we have now advantages of static library. Number one, they are easy like easy distribution. Okay, easy distribution, that is, it is easily, it can be, you can distribute, it is easily, it is easy to distribute. How do I mean? Like, now, when you created your, when you want to create, when you create your static library, okay, all these functions, all these functions, you compile them to a object code, and you take object code and you create a static library from it. Now, all the object code that you created, all the object code that you know the object code, like your this addition.c will now be addition.o. Okay, the .o extension means that it is a um object object code, that is machine code. Okay, um sub.o and .o. Okay, now, I said it is easy distribution. It is easy to distribute. Okay, it is easy to distribute, right? Because all this here, okay, when you that's been compiled and linked into an exec into an it has been compiled and linked into an executable file. So that is, all the dependency, everything has been, like, all the function, look at it, let's say, okay, let's say for instance you wrote over 1,000 functions. Okay, let's come back here. Let's go back here. Here, look at this place, right? Math functions. Now you wrote over 100 functions, okay, 100 functions, and you now create just a single file to add to to store all these 100 functions inside a single folder, inside a single file. Okay, inside a single folder, inside a single container. Shey you get? Now all these 100 functions are now stored, okay, inside a single file. Okay, and that single file is linked to your program and give us an executable file that we can use. So I can just, if I want to just give you, like, I want to give you my, what's it called, my library. I just give you, just upload it to my GitHub repo, or my GitHub repo, and you can download it from there and use, because all the packages, everything is inside that file. Is it the addition you want? Is it the subtraction? Is it the multiplication? All the math functions are inside just that single file. Okay, so that is why it is easy to distribute. Now, number two is that it improved performance. Improved performance. Okay, so it improved performance because the files is linked, like, it is linked into the program directly. So directly we link, like, it is linked, like the code from static library. Let me just put this, let me write it now. Say, now the code, since the code okay, from the static library is linked into your program, or into the program directly, to the program directly without you know thinking of like externally, without thinking of dynamically loading or linking. Okay, linking. So since the code from static library is linked into the program directly, that is, you don't, so you worry. Okay, without thinking of dynamically loading or linking. And since the code static library is linked into the program directly, so you don't without thinking of dynamically loading or linking or any linking again. Okay, because now, as I said earlier, all my packages, everything, like the math functions, everything is already the math library. All the math function in this life is there. All the math functions in this life is inside that, that single lab, that if that file. So you don't have to worry about loading something from one directory or from one place, from one online platform for you to use it, because everything is there. So you can just input it into your program and run directly, and it will, like the performance, it will give you your expected results. So number three here is portability. Portability. Yeah. Portability, right? Let me do a clean up here. Portability. Okay, so static libraries provide better portability as they contain all the required code within the executable. That is, all the required code needed for that all the required code. For instance, the math library again, the math library we are using before. The math library contains all the required code. Everything you need about mathematics is inside the library. So it is portable, you know, portable, a single file, maybe 1 MB or 1.5 MB. You download it, and you are using it. Okay, because very portable. All right. And again, number four, we have version control. Version control. Version control. Let me do a cleanup again. Now, version control. Static library allow you to control the specific version of the library used by a program. That is, allow you to control the specific version of the library used by a program. That is, you can control, okay, you don't want the latest version of this code, of this function, because because if you need to get a new version of that library, you have to to relink it again, right? And or probably download another folder, so another file. Okay, so you can really control that. Okay, I don't want this file now, I don't want this upgrade now, this stuff now. I want the one I'm using. That's the one I'm using. I'm still okay with it. All right, so you can do it. It's based on you. Either you want a new version or you don't. Okay, and also for the programmers that are writing the functions, you know You can keep your track of, okay, now this is the another version of my library. You can have library 1.0, library 2.1, 3.1 of that same specific, of that same library, that is your math library, your mathematics library. You can have 1.0 library, math library, 1.1, 1.2, 1.3, 1.4, like that. Okay, so you keep track of the versioning. Okay, keep track of your progress, you keep track of your, of your skill. All right, so yes, we have the advantages of static library. So let's look at the advantage real quick. The advantage of static library. Right, now number one, so number one, we have a increase you have increase executable size. So yeah, increase executable size, right? So since the code from the static library is included in the executable, okay, mark this, since the code from the static library is included in the executable, it can lead to large executable file size. This is because each executable that uses that the static library will contain a copy of the library code, okay, potentially resulting in code duplication. Okay, okay, it's because each executable that uses the static library will contain a copy of the library code. Okay, because potentially resulting in code duplication. Okay, so number two, uh, we have a lack of runtime flexibility. Lack of runtime flexibility, right? Okay, let me do a clean up again. Okay, now file libraries are linked at compile time, meaning that any changes or updates the library require recompilation and relinking of the entire program. That is, this can be cumbersome, that it can be very cumbersome if frequent updates or modifications to the library are necessary. Okay, like file library are linked at compile time, meaning that is, whenever you want to, for example, to update your library again, you have to relink it, and there will be a multiple of like another, meaning that any changes or updates to library require a compilation. That is, if you make any changes to your program, you have to recompile it again, or and relink it, and relink the entire program. Okay, and this can lead to what, cumbersome or frequent updates. When you have a frequent update or modification, and it will, it's very cumbersome, because you have to recompile, you have to recompile, relink the whole entire program all over again. All right. Yeah. So let's move on to the next one, dynamic library. So what is dynamic library? What is dynamic library? Dynamic or shared library? Or shared library? Okay. So or shared library are libraries are libraries are libraries that include that include okay sorry already that are loaded that load that are loaded and linked link at the runtime at the runtime than being included at the um, than being included directly into an executable file. Okay, so a dynamic library or shared library are libraries that are loaded and linked at runtime. So we load dynamic library at you know we load them and link them at runtime. Then than being included directly in an editable file. Static library we directly you know we directly link them into an executable file into our program directly. But dynamic library or shared library are just library that are loaded and linked as runtime than being and linked as runtime. Yeah. So they provide a way to share code across multiple programs. Okay, allowing efficient code reuse and modular development. Right. So dynamic library or shared library provide a way to share code across multiple programs because we are dynamically um, linking or loading our libraries to our program at runtime. Okay, we are dynamically loading our libraries into and link to our program at the runtime. Okay, so that's why it gives us a way to share all across multiple programs. Okay, it give like allow us to share it on multiple program and allowing efficient code reuse and modular development. Okay, okay. Let me write it here. They provide a way to share, code code across across multiple program. Exactly, multiple programs, allowing efficient 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 you know efficient code reuse and modular development. Okay, development. So now also we have advantages and disadvantages of dynamic library. So the dynamic library, the way they are created is same way as we create static library. Okay, but in dynamic library we use, instead of dot a extension, we use dot so extension. Okay, extension. Okay, so let's let's see the advantages of dynamic library and its disadvantage. Advantages, advantages of dynamic dynamic library. Okay, number one, I will quickly run through this. Reduced, it reduced, it reduced memory usage. It reduced memory usage. You know, unlike static, static does not reduce memory usage, because whenever you want to do any modification, any compile, any adjustment, you have to recompile, and sometimes you have a double, double stuff, a double a double function inside a file when you try to modify some things there. So and with that it gets larger. So but with dynamic, because we are loading it dynamically, so it reduces memory usage. Okay, and number two of this is flexibility and modularity. Okay, so obviously it's flexible to use, flexibility and modularity. Flexibility and modularity, that is, we can create a model of, yeah. So yeah, as I explained, okay, I click copy and paste this thing here so that we won't take much of our time. All right, so reduce memory usage. Okay, so shared libraries are loaded into memory only once, so regardless of the number of programs using them. So once you load shared library, dynamic library into memory, it loads only once, regardless of numbers of programs using them. But in static library, now for instance, if main.c, okay, inside main.c, okay, we have um 4 5 function. Let's say okay, I'm trying to, let's say, let me draw a big something here. Okay, now inside our main function, now example of static. Okay, static. Now let's say we in our program, we are using math function. Okay, we are using string function. Okay, and we are using what again? Yeah, I was in those two. Okay, or we are using money function. Okay, and each one of these, money function has its own library, string function has its own library, and math function has its own library. Okay, so when we create our program, now our main program is calling a math function, like is using library in is using resources from math function, It's using resource from string function and using resource from money function. So our program will have to call to we have to call this math function. That is, our program will be what? Our program will be will link to our program will link to be this way. Our program will link to 1, 2, 3. So here, we have um math library, okay. Here, sorry, we have string library, okay. And here we have um money library, okay. Now our program is using resource from math library, string library, and money library. So this program, I'm trying to explain this, that it reduce that shared library are loaded into memory only once, regardless of the number of programs using them, okay. More program using them. Now, so I want to now explain now. Let's say for example of static now. In static library we have math function, string function, money function, and they have math library, string library, money library. So inside our program we are using inside our program up to we have up to 5 function, okay. Up to 5 function, okay. Let's say 3 function, okay. Here we have function 1, func 1, sorry, we have func 1, okay. We have func 2, I have func 3. Now this func 1, func 2, func 3, this func 1 is using math library, this func 2 is using string library, this func 3 is using money library. Now this func 1 will have to what, in static library we link, what was it called, we link our library directly to the program, right? So to give an executable file. Now this one math library is linked directly to the what, to the function 1. That is, this function 1 will have access to everything inside this math library. So now this math library will be inside this program. this string library, we have access to everything inside this function too. We'll have access to everything inside this string library. So now what this string library will be inside this function, this program. So we'll be having, now let's assume that we have 1,000 or 2,000 function inside math library. So everything will be inside this program. Now we have string library too, and we have 3,000 or 4,000 in functions inside string library. So this function two and this program now, function one, function two, function three are inside this program, this one program. Now this function two, we have to what? So this string library will be inside this function, this program. Okay, that is math library, everything inside math library, the space, everything will be inside this program. When this one make its own call too, the space and this thing make its own call using resource from string library. So everything inside this string library will be copied inside this program here too. So another space, let's assume that we have 1,000 space here, 2,000, 3,000. So we now have 1,000 plus 2,000 plus 3,000. That is 1,000 space of memory, 2,000 space of memory, 3,000 space of memory of this math library. Math library is 1,000, okay, plus this string library when this function to make call in string library. So everything in string library will come with this program, and we have, let's say, 2,000. It takes 2,000 space, and this money library too, when this function 3 want to make it call to this money library, and money library, everything inside the money library will be imputed inside this program. And this function 3 has 3,000, and this money library also, assumption we have, it occupies 3,000, space. So we have 1,000 plus 2,000 plus, so we have 6,000, memory that is taken, that this program alone is taking. Now compare to shared. Now let's compare it to shared one. Okay, to shared example. Compare to shared to dynamic library. Dynamic library. Put example dynamic, right? So we have both math func, we have string, right? String func, okay, and we have money func, right? Now our program, is making calls to one, two, three. Okay. So we have maths library, right? We have string library, okay, and we have money library. Now, and this is making a call core, don't mind my drawing, core. Now this function func one, func two, func three. Yeah. So func one, func two, func three. Now this program also, now this dynamic library, right? Example of dynamic. Now we have math function, string function, money function, and everything is as math library, string library, and money library. Okay. Now all these money library, string library, math library will be loaded once. Okay, will be loaded once inside this program. You know, here we are loading everything in this, everything we are loading it, right? When this call, this one, it bring it. When this one call, it bring it. When this one call, it bring it. But here, once we put these guys here, the math library, the string library, the money library, okay, it load everything, just everything like this once inside this. That is, when this function is making calls, like it is using this library, okay, load it once into this program. This string calls, when this function 2 is load it once, function 3 it load it once. Okay, that is what I'm saying here is, now here let's assume that this function 1 and make it call, right? Now again, this function 1, there's another call again. Okay, I'm saying to get it very well. Now this function 1, maybe it has some other thing that's making call. Okay, these two, okay, and this. Okay, so maybe this as another sub fork func, okay, these two as another sub func, okay, another sub func, and this as another sub func. Okay, let me place this here. Yeah, okay, subfunc, subfunc, subfunc. When this guy, this function 1, when it load its library, okay, and uses its library, then this one will be loaded inside here. This one to be loaded inside this program. Now when this sub function 2 want to access this math function, okay, you have to load it again, enter, load again, enter, load again, enter. Okay, but here, okay, once this math library, string library, money libraries is loaded into this program, all the sub, if you have 2 sub, 20 sub, 1 sub, 3 sub, 4 sub functions under all these guys, it will be just the ones that are loaded here, that's what they'll be using. But this one, if we have 5 functions under this place, it will load this math library 5 times. If you have 5 functions under this too, it will load this string library 5 times or 7 times, based on, depending on the number of functions that is being called to that library. Now here, when this function 1 has, let me put it onto sub, okay, sub, okay, sub, okay, subfunc 1, So func two, and so func three. Now this subfunc, they will still be using the loaded library that is already the man library. Once it's loaded in this program, this subfunc, no matter how the func we have here, they will still be using this math library. They won't load it again. Okay, this one will be loading, it won't load again because it's already loaded once inside it. So this one is what is constant. This one is what is increase in the input, increase in the functions here, increase in the course. This one is constant irrespective. Okay, yeah, that's on this what reduce memory usage. Now, flexibility and modularity. Shared libraries enable dynamic linking as well, yes, and allowing programs to use new version of the library without recompiling or relinking. In static library, you have to what recompile whenever we what we whenever we do any whenever we update it or we do any we we um we change anything inside the form inside the library, we have to recompile and relink in static library. But in what's it called, in dynamic library, we don't need to. Okay, because we don't need to recompile because it is loaded dynamically into the program. Now, code sharing. Multiple programs can share the same instance of a shared library, leading to efficient disk space utilization and easier distribution of updates or bug fixes for a library. Alright, so let's check out the disadvantage. Okay, disadvantage, advantage of dynamic library. Number one, dependency management. Okay, dependency, yeah, management. Now, shared libraries have dependency on specific version of other libraries or system components. So you're looking at the advantages of dynamic library. Dependency management is, you know, shared libraries have dependency on specific version of other libraries or system components. Like they have a dependency issue in dynamic library compared to static library. Static library, there's no dependency issue. Now, because all the your programs in static libraries, all the dependency required for that library is included, but in dynamic library it is not. Now, performance overhead. Dynamic linking involves additional overhead compared to static linking. Okay, this includes the need to locate and load the library at runtime, symbol resolution, and potential function call indirection, which can lead to slightly slower program startup times. Okay, and again, but in what's it called static library, we have a good performance. Now, number three, versioning complexity. Managing different versions of shared libraries and ensuring backward compatibility can be challenging. Okay, yes, because versioning is very complexity in dynamic library, because managing different versions of shared libraries, we have different versions of shared libraries, can be very tedious to manage alone. But in static, it is easy to manage. All right, so easy to manage. Okay, so now let's do a live demo on how to create static library and dynamic library. but for today we're gonna be creating only static library. Stay tuned. Okay, so I have opened up my terminal, my VS Code. So we're gonna see how to create a static library. So for today's video, we only be creating a static library, while I will create another video where we create a dynamic library. All right, now let me just create. So the first thing to do when you want to create a library is that you have to create a an include directive file, like include directives file. So now I want to create a math function library. So I'll call it math.h. Okay. Worry about that. So let me just create touch.file file2.txt 666. Worry about what I'm doing. Okay. What we'll be doing, what we'll be creating. So let's number one, what we'll be doing today, we create math.h, that is, we create an include directives. Okay, so after that we create our functions. That we will create the math functions. Then three, we compile into machine code. It is object files. Number four, we create a what? We create our main program. Okay, create our main program. Number five, we linking. Okay, so number one, let's create our math.h. Our directive includes directives. So math.h, there it is. So the first thing you have to include, like if not define math_h, so define math_h. Okay, so inside our math.h we include our prototype, int addition. Okay, addition, int a, int b. Okay, int subtraction, int a, int b. Okay, you have to use float division. Okay, int a, int b. Right. Then int multiplication, int a, int b. Okay, so I'll be creating these four function and if. Okay, so here I'm saying that If my math.h is not defined, define it. Then I add my prototype. Okay, so next is to create these files: addition function, subtraction function, division function, multiplication function, one by one. So addition um, chmod 666 addition dot c okay. Now let's create our first function, our first math function. Okay, the first thing we're going to include our directives, that is our math.h that we created the other time. Then other approach, we do our what? Int a, int b. Okay, don't mind that one. Return a plus b. Okay, a plus b. So I am done creating this. Then let me create my second function. Search sub c chmod 666 sub.c. So I have to create my subtraction function. The first thing, I will include my maths.h directives, then int subtraction, int a, int b, right? So return a minus b. I'm done writing my second function. Then my third math function is division. div.c chmod 66 div.c. Okay, division, we'll create that too. First thing I will include my main dot my math.h directive, right? Then int, it is the prototype is float. Check it out. Prototype is what? Float. Float div int a, int b. Then I will return a divided by b. Okay, a divided by b. All right. Then my next one is to create touch multiplication dot c dot c chmod 666 multiplication dot c. All right. Then include maths.h. Then int multiplication, that is int a, int b, and return a times b. So now I am done writing my function, my math function. Okay, I'm done writing my math function. The next thing we're going to do is let's check our list. The next thing is to create, I've done this, compile into machine code, that is object files. Now I have to compile my addition, subtraction, my math functions into object code. that is object files. So we have gcc. To do that, run gcc -c addition.c-o addition.o. Now the C is to want to compare to addition.c. That is, now dash o output. I want to output it into addition.o, or that is, I want to compile it into a into into an object file. Then I'm done. Then I will do it to everything one by one. See, then next one is sub.c 0 sub.c.o gcc-c. Next one is div.c-o div.o. Next one is gcc-c month.c-o month.o. Right, so I am done compiling them into machine code. As you can see, now they are now machine code. Now I think they are now object files. Okay, now let's move on to the next thing. Right, the next thing, let's check our list. Then let's create our main program. Right, touch main.c chmod 66 main.c. Okay, now let's create that one. So include input and output stdio, then include my directives, my main math.h directive 2, where all my prototypes are, where I declared my prototype. Okay, now int main, so we have, I create int a equals to 5, we call it 10, and b equals to 5. Okay, so print f. Okay, print f percent d new line addition. I want to call it directly addition a and b. Okay, print f d new line subtraction a and b. Print f percent d. Okay, multiplication a and b. The fourth one percent d percent 0.2f. Div a and b return 0. Now I have to compile. Now I've created down 2. Now linking, let's link our main program with our, oh sorry, there's one thing left. Create library for create library. Five, 6. Now we have to create our library. Okay, so to create a library, GCC, I said static library are a collection of object file into a like linking them into a single file, right? Now GCC hyphen C. Oh, sorry. No, no, no. Um, um, so we want to create our library. To create library in what was it called on Linux machine, we use archive. We archive them. That is AR for archive, RCS. Replace change and oh, sorry, no, um replace. C stands for curate and S stands for symbol. Yeah, symbol. So archive RCS, then our library name lib math.a. Okay, math.a dot a, then our object files, that is our first addition. So here we have dot we have four functions here, dot o function here, dot o files, right? So you can use wildcard dot o extension. Now I have created my library ls. This is my library. I said dot a extension means it's a library file. That is, whenever you see dot a extension file, is a library. Now let's now link it to our main function, our main program. GCC C, sorry, hyphen L okay, GCC main dot C hyphen L, that is the directory, that is specifying a directory, that is the directory of where our library is. In our case, it is inside our current directory. You put dots. Okay, that's current directory hyphen L math. Okay, that is in when you're using GCC. Okay, so GCC is smart enough to know that this math is a library, is a we omit the prefix, right, the lib, and we omit the suffix dot a. So GCC is smart enough to know that I'm trying to link it to a library. So you don't have to include this lib and this dot a into it. Okay, then dash o output, I call it program, call it main program. Okay, now it ran, it went through, then let's check main program. Yeah, it worked. As you can see, a 10 plus 5 15, 10 minus 5 5, 10 times 5 50, and 10 divided by 5 2, which is correct. Yeah, so this brings me to the end of this video. Please, if you like this video, please subscribe to my Please subscribe if you like to see more of this. Thank you. See you in the next video.